Chapter 16, Think and Explain. Got 3 problems from it. So number 47, many tongues have been injured licking a piece of metal on a very cold day. Why would no harm result in a clean piece of wood were licked on the same day? Notice they said clean. That's so they no harm. They want to get away from the germ aspect of it. So when you touch something wet or touch something to the metal versus the wood, basically, if you are warmer than the metal or warmer than the wood, then heat is going to go away from you into the colder object. This is, we'll later talk about that being the second law of thermodynamics. Things flow from hot to cold. So the question is, how quickly does the energy go away from you? And for metal, it conducts it much faster than wood does, and so you get the much closer to instant freezing when your tongue touches the metal. So basically, the saliva freezes, and it's, not just on the surface of your tongue, but obviously a little bit into the tongue, and thus sticks. And so if you pull off, you'll take some skin with it. Same thing can happen with ice cubes. If you have a cold enough ice cube and a little bit of moisture on your lip, you can get an ice cube to stick to your lip. And basically, if you try to take the ice cube off, you'll take part of your lip with it. It's not like you'll have a big gap there. You'll just miss some epidermal, some of the outer layers. So wood, on the other hand, does not conduct it particularly quickly, and so in order to freeze the saliva on your tongue, you have to be out there a long time. And I doubt if anyone has the patience to stick their tongue out, touching a piece of wood out in cold and freezing weather for that long. But I guess, potentially there's a masochist out there somewhere who enjoys that. Number 64. Air density is normally less than any point in the air than below, above any point in the air than below, because the density increases as you get farther down. Refer back to chapter 14. So, providing a migration window in air, how does this affect the movement of faster molecules in the air? So, you have a molecule that's moving fast for whatever reason, then basically it's going to move fast until it hits something slower, at which point it will slow down, the other one will speed up. So, as a general rule, you'll have at upper levels, because the density is less, these fast-moving particles are more or less apt to run into anything. So therefore, fast-moving particles will still travel faster because there's fewer collisions than down below. So you tend to get stronger breezes the higher up you go than down below. There are a couple ways of looking at that. You can also look at it from the point of view that since the air is traveling faster up above, there's less pressure, and so there's a general force of pushing pressure up. Another way of looking at it is particles are moving in sort of random directions. This is known as Brownian motion. And so the particles that are moving up, it's more apt to get hit by a faster moving particle. And so if I have a particle down here and then one zipping along this way, this one just happens to be randomly going up, there'll be a collision. So this one will go shooting off faster. And so statistically speaking, which is the hallmark of almost all thermodynamics, statistically speaking, you tend to have air moving up and faster the higher up you go. And then 67, ceiling fans can make you feel cooler in a warm room. Do ceiling fans reduce the room temperature? Not the average temperature of the room. It does shift hot air from or cold air from one spot to another. Please note that if it is hot air rises, as generally it's termed, very much related to the previous question that we had. Hot air statistically will be at the top of a room or an enclosure than at the bottom. And so, therefore, if it is summertime, if you have the fan blowing down, you're basically taking the hot air up top and you're shifting it down. And so, although you might feel cooler by basically you're hot, and so you're sweating, and so you're blowing air across it, but that is not going to make you the coolest. Actually, in summertime, you don't want to blow the hot air down. You want to draw cold air up and, in essence, push hot air off to the sides. And so you want the fan to actually be sucking air upwards in the summertime or in hot weather. And so that way the cool air is coming up. You're still hot, but the overall temperature in that mid-level should actually reduce some. Now, in wintertime, you do want the hot air blowing down, so you want the fan blades to turn so that they blow downwards, blowing the air down. And I've been in restaurants which have the fans backwards. In summertime, they're blowing air down, thinking of you want a fan blowing on you, but all they're doing is just blowing hot air on you. And it does actually reduce overall temperature. misworded. It reduces the temperature where you are. If on hot days you blow the air, you suck the air up instead of blowing it down. And anyway, that's the thinking explained from chapter 16.